Welcome to the Data Leaders Podcast live at RetrieveX. I am your humble host, Sinan Ozdemir, for the first few interviews here. Thank you so much for joining us on this beautiful San Francisco morning. I have with me right now Prasanna Desikan, Head of AI at PrimeOrbit. Thank you so much for being here.
Thank you, Sinan, and thank you, RetrieveX, for hosting me for this podcast interview.
Yeah.
Glad to talk about here.
Tell us about PrimeOrbit for the uninitiated. What is PrimeOrbit?
So PrimeOrbit is an early stage startup company in the cloud management sector. And we are an AI-driven cost optimization solution. Now, you may wonder that, hey, this is a known problem. There are many vendors in this space. What's special about it, right?
That's exactly my first question. What is special about it?
So let me first talk about why we are in this space. This is like search, right? Search is not a solved problem, right? You can say, hey, the problem of search has existed for long. You're not solving a new problem. No, the problem is not solved. And why is it not solved? You realize that cloud cost optimization is still the number one concern for all CIOs in large enterprises managing multi-cloud environments, right? So it's not a solved problem. There are many companies working on this, doing some good analytics, capturing all the low-hanging fruits and all those kind of things. But what is missing here and where we come in is most of these solutions are missing the business context. How does the organization work? What is the business context? What are the organizational structures within the business? So we are not just focusing on the machines, but we are trying to optimize the cloud spend based on how the business works, what are the goals of the business, and so on. So that's where PrimeOrbit comes in with our AI-driven solutions, which we are building, leveraging all the state of art and actually going beyond that. We are doing our own applied research and building more AI techniques to build that rich business context that makes sense when you optimize your cloud spend, because you're not just optimizing based on the infrastructure, but you're optimizing based on the business as a whole. So that's where we are championing, and that results not just in better savings, more understandable savings, more strategic savings, and we also take it a step beyond and say, hey, we are not just going to provide you the insights, we will help you, because one of the big other problems is, hey, I provide you the insights, what next, right?
Right.
And using AI, again, we are able to do workflow optimizations and speed up the execution of what we recommend so that you can achieve your optimization at a much more rapid pace, right? So that's where we specialize in, and that's what we are proud of, and doing some great work there. And that's the AI layer, and of course, there's also the agent layer, which we are building, the AI agent layer.
We'll get to the agent layer in just a moment. One of the things I really loved about what you just said, and I think this is true for a lot of AI-driven companies these days, which is there's a big distinction between providing insights and being actionable, right? I think a lot of people would put those things together and say these are actionable insights. But what you're saying with PrimeOrbit, it takes that one step further, which is not to say not only are the insights we're providing you actionable, we will actually help you take those actions as well. So I think my first question to kind of follow up on that is, how does, because I'm assuming the agent layer is part of what actually takes those actions on their behalf, but even before we get to taking those actions, tell me more about how PrimeOrbit is contextualizing a business and actually using that information to provide those actionable insights.
So if I understand your questions right, there are two parts to it, right? One is, how do you enrich your data with the business context? Right?
PrimeOrbit's data or the customers?
Customers' data.
Perfect.
Right. PrimeOrbit will also have some amount of data based on our domain expertise that we will add on, right? So that's one question. The second question is, how are you then automating it, right? Or how are you taking it to execution and things? Two separate parts. So the first separate part is we have all this business data based on all the business documents within our organization, right? So we mine them, we create knowledge graphs, and have a context associated with we know the applications they are running and what are the purposes of those applications. So we know all of this data, and we are contextualizing this using some advanced techniques. And one of the very basic things that cloud people managing cloud would realize and would appreciate is tagging, right? People tag, right? So, and there are only like many organizations, there's 20% compliance. But tagging is, and this is just one of the things, tagging as an example, tagging is a powerful tool to label machines on what they are doing, right? And
you're talking about tagging, like this server is for this type of compute, this server is for this reason, or how do you mean by tagging?
Yes, this server is for this type of compute, but this also serves this business purposes and is running these applications, right?
Got it.
Right. That's the business context, right? It's not about, oh, is this development, is this staging, is this testing? Those are important. Those, I'm not saying those are very important, but we want to go beyond that, right? And that's where the gap is. And we have actually developed some pretty neat clustering techniques, which are not existing today in off-the-market tools, and we are leveraging techniques from web mining and link analysis and all of those things. And we are even doing better than you ask LLMs to cluster a set of words or some standard words. We are doing better than that. Why? Because we understand the domain. And we are saying, okay, we understand the domain, and as AI experts, we know how to model the problem, right? And that's, I mean, you probably know this really well, is half of the, or 80% of an AI solution is the data pre-processing and the modeling.
Oh, yeah.
Right? So that
mostly the data pre-processing,
mostly the data pre-processing, but then the next step is the modeling. So, and that's where we innovate, and we are able to really come up with excellent tagging, right? As one example. So that's where that answers the. So we have some really good advanced tagging solution. So that's the example of the business context, right? Now, in terms of automating actions and stuff, so you discover these insights. And then there are, for example, one of the things is, hey, I need to shut down a machine, or I need to delete an instance, or
you have too many, containers for this one thing.
Right,
you scale it down.
So if you think about what a person would do, he would go and write some scripts and do a set of tasks to do that, right? Now, what we can do is, if these are standard tasks, and as we learn how to do this, we can generate scripts. And if you give us permission, we can run it. We are not going to automatically run it.
This is the agent layer you're talking about. Is that right?
Yeah.
Okay, Tell us more.
Yeah. So we can automatically run it, right? Once you develop the context. And this is not a new, the agent layer is a very good concept and all that. But the whole idea of automating
robotic process automation, RPA.
Some
many
of these
names
have
over
existed.
many, yeah.
Some of these have existed, and we recognize the importance of a human supervision too, because your production system, you don't want to automatically shut down things, right? Even back in the day, 20 years back, when I was working on intrusion detection systems, the idea was, like, say, for example, to reduce 10 million connections in a 2-minute time window to a set of 100 connections that are anomalous, for a security analyst to look into and say, hey, are these threats, right? Because he cannot, it's a cognitive reduction.
Right. Instead of mining through thousands of logs, here's your short list.
Yes.
Now
we present, hey, here's a problem, here's a script we have generated for you. If you're okay to run it, or if you know something else you want to add, modify, you can do it, right? Or if you think, hey, you're comfortable enough, you want us to run it, you can run it, right? So that's where we're going.
Nice. So you brought this up yourself. You've been working in this industry for a while now, from intrusion detection, now at PrimeOrbit. Tell me about one of the, what I would call the short-term trends that you personally, and maybe PrimeOrbit, has been tracking in terms of just AI innovation, AI implementation. What are some of the short-term trends that you're noticing and acting on?
Yeah, so on this space, what I would like to point out is when people talk about short-term trends, they typically would like to know one trend, right? But the reality is researchers are working on many different things parallelly. So there are going to be many different parallel trends going on. But what I'm going to focus on is, given the conference and the generative AI space, right now, I think the LLMs, building the large LLMs is mostly going to be for the larger companies, right?
Okay.
Complex LLMs and stuff.
Fine-tuning their own LLMs in that regard?
No, just building completely new models with all the billion parameters and all.
Oh, I see. Yeah. The whole pre-training architecture.
What the smaller companies and startups and what people like PrimeOrbit can do is, how do I improve this? LLM is a general kind of a knowledge base, a mechanism to answer questions. And as you know, it has hallucinations, it has other problems, and people try to mitigate it by using RAG, right? And RAG does not solve the hallucination problem. So there are different ways to solve it. There are data mechanisms where you can introduce RAG and augment the query, right? You're still not changing the model, you're augmenting the query to help the model answer things better, right? From a technical standpoint, you're not actually eliminating the hallucination, you're trying to mitigate it.
Right.
Right?
For example, if you would ask the LLM to maybe think through this before you answer it, cite this before you try to answer the question, some kind of way to kind of get the AI to kind of reason through the document versus just go ahead and answer. Is that right?
Yes. Okay. So there are different ways. There's RAG, prompt engineering does a little bit, and then the more, if you really want to improve your model, is the fine tuning, right? That's also a data-driven mechanism where you provide a pre-trained data and you fine-tune, and there are you either fine-tune the entire model or you be smart enough to fine-tune only certain portions of the parameters.
Sure. Or you some kind of a LoRa technique.
Yeah. So
some kind of efficient fine-tuning.
So RAG, fine-tuning, people are working on this. They want to improve the RAG, they want to improve fine-tuning and all that. And then there is the actual model level mathematical improvements, right? How do I improve my encoding and decoding? Because your hallucination and everything will be resolved at that layer.
You mean the embedding layer, for example? Like the embedding layer?
Yes. It will not be resolved by RAG and your fine-tuning and all that, right? They will mitigate it to a large extent, but it will not be resolved. Right? So there's going to be research going on there. That kind of research probably is more going to be focused on the larger, bigger companies who have large investments research.
This actually comes back to something you said earlier, the idea that some of these solutions are not necessarily solved, but we've been working on them for a long time. Retrieval, I would argue, is information retrieval is not a new subject. The idea that you would retrieve a document from a database given a query, we've had techniques for that, BM25, keyword matching, n-gram search. We've been trying to achieve this for a while. It's only in the last, I would say, 1 or 2 decades that we've been able to implement deep learning, Word2Vec, Doc2Vec, and now LLMs to be able to do that in indexing and retrieval more efficiently. So I see that as both a short-term trend of how do we incorporate databases like graph databases, vector databases into the LLM, but I think it also matches to a longer-term trend, which is we've been trying to solve a lot of these problems for a long time. So I'll use that to move on to kind of more longer-term breakthroughs that you are looking out for, maybe you're actively seeing come up. What are some of the longer-term breakthroughs that you are hoping for or looking at or actively seeing come to market or come to research even?
So the first thing I would talk about is what everyone is expecting, right? And let me put it that way, is right now we are at a system one thinking where we have training time compute. So you build these large models, it's completely trained, and when you get a new problem, you apply the model as is and you do a rapid execution, right? Big models, huge models, LLMs and all those kind of things. So that's the big achievement now. The next step, natural step, which everyone is thinking is this is going to go into a system 2 thinking, or a thinking AI, what they call, where you pause. When you're at a certain stage, you pause and you think and generate all different scenarios at that point using the kind of a generative AI component to see, okay, given at this instance and given all possible scenarios I can think of now, what would be the best option going forward, right? So there is this think and act, but it still has to be done in a very fast time, right?
Right.
It's
reasonable
not,
time. Let's call it a reasonable time. Yeah.
Reasonable time, right? So that's the challenge. So there is a compute challenge and there is the actual model challenge, right? So that's where we would go, right? So we are evolving as we are learning. So we know how to apply existing models very fast, and we have improved models to a large extent. The next natural step is system 2 thinking or thinking AI. I mean, there are terms that are thrown, but that's the pause and think reasoning. Having said that, that's what we are expecting, right? But having said that,
well, that's the well, tell us about reality.
let's talk about a little bit about reality, and let me go back to around 2009. There was a paper called Top 10 Data Mining Algorithms.
Okay. I'm unfamiliar with this one.
Yeah. Okay. So it had all k-means, knave, Bayes, and all, and one of the things was PageRank, right? Google's PageRank. Now, if you think about PageRank, why was it a breakthrough? It was solving a search problem, especially searching information retrieval on the web, right? It was a known problem. We had the bag of words model. We had text mining.
Right.
But why was it a breakthrough? Because they thought differently. They said, hey, I'm not going to just look at the text.
Right.
I have a graph there. The web is a huge graph. There's structure there. How can I leverage that complementary or data to improve my search and ranking, right? More specifically ranking. And it was not, PageRank was not the first. IBM had HITS algorithm, based on hubs and authorities and all that. But that whole idea, the breakthrough was because on the way how you modeled the problem, right? Like I talked about earlier.
Right. The technologies and components may have been the new thing. It was the way of thinking and
Way
putting
of
them
thinking.
together. Right.
So it generated a huge amount of technology and applications and all that. Then around 2012 came the ImageNet paper, which had classified millions of images using 60 million parameters and neural CNNs. So that was a huge thing in deep learning, big breakthrough in deep learning, because your ability to detect images or detect things in images. So it led to Google Photos, Google Lens, radiology space.
We still use ImageNet as a basic data set.
It was supposed to be the next thing. There's a lot of hype and all, but no one was expecting it. Now, as researchers were working on this, there were these researchers who were working still on NLP and text mining and understanding strings of text and stuff. And that's where there was LSTMs, RNNs and all that, and then came the transformer model, right?
2017, yes,
2017.
pivotal moment.
No one was predicted that, right? The 2017 transformer model said, hey, I'm not going to look at things sequentially. I can, at any given point, look and relate words at two different points in the sentences very quickly. I don't have to do it sequentially. I have the TPUs and GPUs that can do parallel processing. So there was enabling technology.
The attention mechanism.
Attention mechanism, right? So the attention mechanism, it was solving the same problem, like search.
And people had been putting attention into RNNs back, even before the transformer. So we were aware that the attention mechanism was enhancing these.
But it's a different way of thinking and the modeling that led to this breakthrough, because it solved the problem in a much bigger way and in a faster way, right? So the point I'm trying to make is there was search, there is image classification, and there is this NLP, generative text or AI kind of a thing. None of these were really predicted, right? No one thought search. Even when Google came out, people were like, what's a search company, right? While I think system 2 AI is going to be the next thing, we never know what the next major breakthrough is going to be, and the next major breakthrough within the AI space is going to be some model breakthrough, right? And the technologies that come, the AI agents and all that, that's a different layer, and there might be breakthroughs in there. We are talking about agents and all those things today. Maybe it's not going to be agents. Maybe we have a different perspective of how to put things together. Agents are probably not enough, right? Today we are thinking about agents, and for the next few years, agent framework is going to be the big thing, right? And how do you, and the key thing even there in agent, what we at PrimeOrbit are doing is we have this AI layer and the agent layer. And one of the big things we are specializing is how do I know the agent has to interact with classical AI or Gen AI, or a combination of those. Gen AI has a lot of hype, but classical AI and the discriminative AI, you give it a certain problem, it does it much faster and much quicker. If your problem is very specific, they can still do it. They can still beat the Gen AI stuff, right? Because they're mathematically very strong, right? It's so for specific problems, and we use those combinations too, like I was talking about clustering earlier, right? So it's how do you understand the AI
How
framework?
do you put all these things
how
together?
How do you put all these things together? And so once you have separated your AI framework that is able to talk to different each other and have it modular in a way that there's a new concept coming in, you can plug it in, and you have your agent layer or whatever layer, API layer separated. Today it can be agents, and it's going to be there for some time. But if that changes, you're still ready, but your fundamental intelligence is going to come from your AI layer.
All right. Well, whatever the next breakthrough is, you'll find it here on the Data Leaders podcast. Thank you so much for being on the show. Enjoy the rest of the event.
Yeah, thank you, everyone.